integrated suite for software facilities for data manipulation and calculation and graphical display. Already we are discussed it. And it is effective data handling and storage facility. So data handling means, so suppose we have to import data from Excel sheet, or you can import data from other database. So you can use, it is easy to collect, or you can easy to import from other calculation, or on nowadays on matrices. You can work with matrices also. And it is a well-developed, simple and effective programming language, which includes conditional loops, like what are the loops? While loop, for loop, and if loop. Okay, so these loops also have some effectively working on R and L. So already we discussed why we are choosing R means it is a licensed version. So many softwares are there, SAS, SPSS, and the remaining statistical softwares are also available. So why I'm choosing R means it is a open source, it's a free software. So you can reduce our economy, or you can control our economy. So how to download R? Okay. So say from installation, say in Google, just type R programming download. See, so the first link, like a cran.r.project.org. Okay, so you can click and you can run this exe file. So it takes only 5 minutes to install your R program. So normally some other softwares like SPSS or MATLAB, it takes time to install. But here, no need of install. It takes only 5 minutes. 5 minutes process. Just go to Google, just type download, or you're getting this link here, cran.org.project.org. So this is the link. Okay. And you can use external data. So you can use external data. Already we discussed it in Excel or some Oracle or Minitab or any files. Okay, you can import, or you can import your files for purpose of analysis, statistic analysis. See here. So first one is our version 4.1.2, and download now. I'm showing recent version. I think day by day or week by week also it is update version is available. So 4.1.2. This name is 4.3. It is a old slide actually in our programming. So actually this is called command line. Command line means you can use some command in this space. So you can type command here, you can run, you can use some functions, any statistical. So this is the command line, or what is the, you can use any statement here. So new script we will discuss later. So new script means you can write the program in new script also. See, new script like x equal to 5. But here x equal to 5 means very quick taken. But here x equal to 5. Argument is visible.
I'm not visible, ma'am. PPT not visible, ma'am.
Visible, sir.
Audio.
Our window is visible.
Visible, sir. It's visible only. Visible only, ma'am.
Maybe you
Suppose if it's not visible, can you start screen, ma'am? Can you start screen?
It is visible, sir.
maybe your network issue, I think.
Okay.
Okay. So editor means like it is a, what is that? You can write program in this editor. So here, just use Control R, see, or you can use directly also. There is a use of this new script. This font size is okay, ma'am?
Yes, sir.
Okay.
Yes, sir.
Okay. See, suppose I want to take a pi square when use x3 equal to -5. So x3, normally in Poisson distribution, I'm using the e power minus lambda by lambda power x by x factorial. Okay. So these functions are just one operation. Tell me. Anybody?
The cos pi.
Cube root, sir.
What one?
Cube root.
It's not clear. Ma. Here it's not there. No issue. I will send that functions. Okay, you can use sine, okay, sine, cos, or star. That is also power. 2 power 3. You can use all are power functions here. You can check now. 2 cap 0.5, 2 double star 0.5, 2 cap minus 0.5, 2 cap 3 cap 2, 2 cap 3, and cap 2. See, normally in our programming, it follows hierarchy order actually. So 2 cap 3 cap 2. So 2 cap 2, 3 cap 2 means it takes 2 cap 9. So it takes 2 cap 9 because it follows hierarchy order. Like C programming or C++, any programming, or follows hierarchy. Okay. Now, how to assign the operators or assign the numbers in our programming? Normally, if you take any programming, it's equal to 5. And equal to is the assignment operator. Equal to is the assignment operator. But in olden version, not now. Now we are using equal to. In the old version of R, they are using this arrow marks. Or use like this. So these three are assignment operators, but generally we are using x equal to. Generally we are using x equal to. Okay. See here. So this assignment operator on the left arrow with the dash. Okay. Are equal to sign. So normally we are taking x equal to. That is better. That is easy. Because if any programming, equal to is the assignment operator. Okay. Say x equal to 5, I is equal to 20. You can use these variables x into x divided by y, x power y. Okay. And next one is the important thing is R follows. What is that? It is a case-sensitive language, programming language. So it takes lower case and uppercase. So small x equal to 50, then I'm taking capital X, showing error because a capital X is not found. Because I'm assigning small case, x equals small x. So then I'm using capital X. So it's showing not found. Not found means it follows case sensitive. It is a case sensitive logic. Then I'm using small x, it's showing 50. There is another thing in our program. So it is a case sensitive logic. Okay. So here, so in this programming, x equal to 50. X equal to 50, it is okay. X equal to 50, it is okay. Suppose I want to include or I want to store two or more values in my variable, like array. I want to use or I want to store two or more data in a single variable. So then you can use x equal to c. C means combined. Okay. 12, 34, 34. C. So you can use this like array. You can use array here, or you can use two or more data from single variable. You can use C. C means combined. Okay. So this is an array or vector. So then I'm using x equal to 1, 2, 3, 4, 5, it's showing error. Then I'm using x equal to c of 1, 2, 3, 4, 5, it's showing error. Again, you can use operators like x equal to y equal to c of same 12. You can use some any operators by using this. Okay. Now, so this is x data. Again, I'm using some other functions. So maximum function will give your data, and minimum function in your data. Minimum observation in your data. Next, sum of all numbers. So it is in ascending order. Suppose I want to take my data in descending order. So how to take it? Soft decreasing. See, I have a doubt. Okay, I have a doubt now, and I want to check what are the it is in descending order. That's my spelling mistake actually. 54, 34, 23, 51. Okay. Now, I want to take. So before sequence of numbers, I will show some other functions available in your functions. Okay. Absolute already we discussed. Square root already we discussed. Round. So round means it takes round value. So round, suppose x equal to 5.6 and round off x. It's round value. Okay. Suppose x equal to 5.6342. 6342, or some other 10 numbers we have. Then x comma 2. X comma 2 means it's showing 5.63. First two digits of a fraction. Suppose I am using 5.634. That is the fraction. Suppose I have 10 numbers. You can use 3 row series, we'll discuss later, and summation, product, logarithm, log 10, exponential, sine, cos, tan. Directly you can use sine, cos, tan, sine inverse. What is that? Cos inverse, tan inverse, and remaining sine h, cos h, tan h. These are the some functions available in your output. Now, I want to take sequence of numbers. Normally, summation equal to x equal to 0 to something. Normally, any binomial distribution or Poisson distribution, summation x equal to 0, 1, 2, 3. Then I want to take sequence of numbers. So x equal to 20. X equal to 20. Here, your observations 1, 2, 3, 4, 5, 6, and so on. You can use minus 10 to plus 10, and you can check your output. Minus 10 to plus 10. Okay. Now, I have some other function. sequence 1, 20. So 1:20 and this sequence 1, 20 both are same. But the difference is, suppose 1:20 means it's showing 1:20. But in sequence, you can change any numbers. See here, 1, 20, 2. So then you can check your output. So 1 plus 2, 3. 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. Okay. Similarly, you can use 3. 1 plus 3, 4. 4 plus 3, 7. 7 plus 3, 10. See. There is a difference between this 1:20 and this sequence. Okay. Now, I'm going to repeat my numbers. Repeat. Why? What is the use of repetition? Means normally in design of experiments, especially in statistics, there is a concept called replication. So replication means repeated number of times. So in this case, I'm using this repeated function. So repeat 5, 3. Check here. Repeat. Suppose x equal to CF 1, 2, 3. Repeat x comma. Check your output 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. Now my question is, suppose I need 1, 1, 1, 1, 1, 10 times, 2, 2, 2, 2, 10 times, 3, 3, 3, 10 times. Then use each equal to 10. Then check your output. 1, 1, 1, 1 10 times, 2 10 times, 3 10 times. So there is a difference. See here. You can check this output and this. Okay. So this is about repeated function. Okay. Now our ID or registration number. So student registration number is 101, 102, 103. Wrong. Second name is, say, any character you must use double quotation. Gender. Again, you can check name. It is a single variable. So how to do the operations by using this? We will discuss now. So this is creation of data set. Next, after matrix, we will discuss how to import a secondary data set. That is, we will discuss in after discussing about matrix. Okay, so this is matrix form. How to create matrix form? We will discuss. Okay. Now, come to matrix. Suppose my matrix form. I will take one matrix. See, 1, 2, 3. This is a common actually. by 4 FTP. First, you can create one variable x equal to C of 462 4 6 2 3 1 1 4 0 3 7 1. Okay. First, we have to take the observations. Now, you can create some other matrix here. A equal to matrix. This is the function. Your observations of x, and first we have to use number of rows. Okay. So how many rows in my matrix? There is a three rows. So n row equal to 3. Okay. And n column equal to 4 you can use. Okay. Or you can use only row. This function, it takes defaultly as number of columns as 4 because our numbers or our observations are 12. That's why it takes by default. By default, it takes number of columns as 4. Otherwise, we have mentioned. Now, pick your 4 2 1 3 6 3 4 7 2 1 0. Now, you know transpose of a matrix. Transpose of a matrix. Okay, I will share that slide. Some other matrix functions are there. You can work out because within short period of time, it is not possible to discuss each and everything. Just give the outline only. So remaining functions, I will share that slide. You can work out. So next, I'm moving to some other step. Okay, or how to import the data after complete this matrix. Okay, see. Now this is the matrix. This is the matrix. Okay. Here, I want to remove this second row. I want to remove this second row. I want to remove. Okay, how to remove this? A, use square bracket, -2, space, there is no column. Okay, then check your output. There is no second. And here I want to remove third column. Third column. Same I am using. In place of there is no row here, you can use -3. -3 means you can remove column number 3. Now check your output. There is no column. Why means in statistics, okay, it is a collection of information. So few variables no need in my data. So how to remove this? Remove my data. Just you can use like this. Okay. Now, for sometimes I need subset of matrix. I want to pick some subset of matrix. See, so this is the matrix. This is the matrix. Here, I need this subset. This subset. Okay. So this subset means which row it is? Second row, third row, second column, third column. Or suppose I need this 1347 means first row, second row, third column, fourth column. See how to take the submatrix. First one is second row, third row, second column, third column. So 3410. So 3410. So next one is first row, second column. Sorry, first row, second row, third column, fourth column. First row, second row, third column, 134. So 134. So this is subset of matrix. Okay. So come to your matrix data frame. Already we discussed it. So this is it is also nothing but creation of matrix. Creation of matrix. Here also I want to remove the gender. So gender means column. This is column. Sorry. Check your decision. Okay. Similarly, I don't need this third column. Third row or fourth row you can take. -4. First page here. Now check 101, 102, 103. There is 104, 105. So this is about suppose any value is 0, you have to remove the data, then you can use these functions. Okay, already we discussed it. What are the contents or what are the how to create the data frame. Okay, now suppose my data is available. My data is available in secondary source. My data is available in secondary source. So this is the data. See here, registration number 101. So I'm taking very simple data. Normally data is not like this. Normally in statistics we have very big data. So here for understanding purpose I'm taking very simple data. So registration, gender, marks, language. Okay. But my data is in the form of Excel sheet. My data is in the form of Excel sheet. Now, how to import this data? How to import this data? So all of you listen carefully. This is very important thing. So my data is an Excel sheet. So first we have to save your file in CSV format. That is the main thing. See, go to save as. Use some other place. I'm using desktop, or you can use my documents or some other your location. Okay, I'm using desktop. See, your your file type must be in CSV. CSV, comma delimited. There are 3 CSV. So the other one is Macintosh. The other one is MS-DOS. Here I'm using CSV, comma delimited. So you must save your file in CSV format. That is an important thing. So first we have to enter the data in Excel sheet. Next, you have to save your file in CSV format. You can choose some location, either in desktop or downloads. You can choose. Okay. Already my file is there. It is in desktop. It is in desktop. Okay. Now, how to import my data? How to import your data? See, first I'm using one variable. What is that? Class. That's one. The variable. Here you can use the function read.csv. Read.csv. Now, read.csv. Now, use double quotation. Use double quotation. Now go to this file. Choose location. So how to choose the location? Then right click, go to properties. Here you have location. Location is your path. Okay. Just use your location. Come to our window. Then enter. And what is your file name? File name is student. What is the extension? It is in CSV format. Okay. Now, the important thing is it must be in double slash. It must be in double slash. Okay. This is your data. This is your data. Suppose we want to use single slash. Double slash. So this slash means double slash. This slash means single slash. You can use any one. Say, suppose I'm using single slash here. Showing single slash here. Showing error message. Okay. So one thing is double slash. This is single slash. So these two functions. Okay. Import your file. Okay. So first you have to enter the data in Excel sheet and save your file in CSV format and choose your location and take your variable data set in and what is your extension name. It in CSV. Okay, just you can run it. It's showing separate result, separate data set, separate. Okay, so this is import of your data set. Okay, okay. Now the other important thing is already I have data set. Here I have 4 variables, no issue. I have a data set actually, but I don't know how many variables in my data or how many observation in my data. So in this data set, it is very easy to understand 4 variables are there, 10 observations are there. Okay, here there is no problem. But generally in practical applications, in secondary data set, it is very difficult to understand or difficult to take how many variables in your data, how many observations you have, because all variables is not useful for analysis purpose. You have to pick only few variables based on your objective. Depends on your objective. Okay, so it is very easy to understand. Suppose in case your data is very big, how to check it? That is very simple. STR. STR means structure of your data set. Now check it. Structure of your data set. What is your structure? 10 observations of 4 variables. 4 variables standard. And registration number. It is integer. Gender. It is in character. Marks. It is integer. Language. It is in character. Okay. Automatically it takes what is integer, what is the character, what is integer, what is the character. So this is the structure of your data. Okay. Now, suppose I have very big data set. I want to pick first five or first 6 observations in my data. I need only first 6 observations. Then I use head. Class 1. Showing first 5 observations. Suppose if it's 7 observations, showing only 7 observations. Okay. Suppose I need 10 to 7. Okay, this 7 to 10. So 4 observations. Last 4 observations I need. Then you can use 8 class 1. This is last 4 observations. This is last 4 observations. Already in matrix, already we discussed it. Suppose I need a 3 to 6. 3 to 6. Only this submatrix. Anybody tell me what is the statement? Anyone tell me? Already we discussed it. First we are taking first 5 observations. Next 7 observations. Next last 4 observations. So first is last only. I need middle one. I need this 3, 4, 5, 6, 7. Then what is the statement? What is the code?
Between, sir?
3 to 7. 3 to 7. Only 3 to 7.
Between command, sir?
Already we discussed it. It's very easy. See, class 1 is a matrix. Okay. Now, 3 to 7 rows, and this is 1, 2, 3, 4 columns. Okay. 3 to 7, 1, 2, 4 columns. See your output. Your output is this. Your output is this. Okay. It is also submatrix. It is also submatrix. Okay. Now, it is your data set. Already I have a data set. Okay. I want to take only one variable, marks or language, in my class 1 data set. In my class 1 data set. So what is the variable here? What is the function? Class class 1, okay, and marks. So class 1 is a data set, box is a variable, that variable name, that is observation name or variable name. So in between, you can use dollar symbol. Registration number, normally registration number is only for verification purpose. We are not doing any calculations on registration. So gender is a character. So that is a different, we have categorical data. Language is also character. That is also categorical data. We can do any mathematical or statistical functions by using this quantitative variable. So how to take different separate variable? So class 1, already I have data set. I want to pick only one variable. So your data set name and your variable, in between I can use dollars. You can use dollars. Okay. Now, again, this is your data set. Come to here. Now, only I need male data. See here. Male, female, male, female, male, female, male, female, like that. Okay. And Tamil, Telugu, Hindi. I need only male data and I need only Tamil students in my data set, or Hindi students or Telugu students. Only one based on your, it is a subset. Okay, it is also subset. So here you can use, first you can use class 1. What is it? Data set name. What is the variable? Gender variable. Then use the function subset. Again, can use class gender, or I can use gender 1, I think. Gender male. Okay. Can use subset. Class 1 is a data set. Gender is a variable. Comma. Again, you can use same here. Then double equal to the double quotation. Which observation? So male observation, female observation. Male observation side. Sorry, mistake. Sorry, there's a mistake here. Subset class gender. There's a mistake here. Class 1, dollar symbol. Okay. I'll check your output. So in my data set, already changed all female. They're wrong here. It's not found. Okay, I will check and I will let you know. There is a mistake here. Okay, no issue. But this a function is there. How to take your male data separately, how to take your female data separately. We have some functions. Okay?
Actually, we want all those registration numbers.
Sure, no? My question is, I want to pick only male data separately, female data. I want to take male data separately, female data separately. I will explain. I'm sorry, I will explain. So I will move to some other function. Okay. Now, normally, classification, tabulation in statistics. So classification or tabulation, suppose see table. Okay. Table. Class 1, dollar symbol, gender. Data, how many males and how many females in my data set? How many males and how many females in my data set? So you see here, male is 5 and female is 5. Similarly, I want to check language. Students are 4, Tamil students are 3, Telugu students are 3. Okay. So how many students or how many observations, repeated observations in my data? Next, not two-way table. So two-way table is how many male students in Tamil, how many male students in Telugu, how many male students in Hindi. Similarly, how many females? So gender and language you can take. Okay, for two-way table. Same table function I'm using. Class 1 gender, comma, class 1. Tamil, 2. Okay, this is about your data set. This is about okay. Tabulation, presentation of your data. Okay. Now come to graphical presentation of your data. Normally, you know graphs. What are the graphs available in statistics? Line diagram, pie diagram, bar diagram. Different diagrams are available. Okay. So already I have code. Just I will run that code. Okay. See, first I am taking x equal to C of 21, 62, 10, 53. By x. And check your output. Your output showing like this. Okay. But I want to give some names for 1, 2, 3, 4. So these colors are not good one. Okay, you have to change the colors also. Very different colors you can change. First one is you have to change the name of 1, 2, 3, 4, and you want to give the title for this chart, and you have to change the color. So what is the code? See here. You have to enter the labels. Okay. So labels means 1, 2, 3, 4. So 1 is London, 2 is New York, 3 is Singapore, and what is that? Fourth one is Mumbai. Okay. Now take your output. Your output is showing this. London, Mumbai, Singapore. Now I want to give the title of this chart. I want to change the color. I want to change the, see how to change the color. It is also available. Again, I'm taking separate code. See here. If you check your statement by X, okay, X means this observation. And labels. Labels means 1, 2, 3, 4. What is 1? What is 2? What is 3? What is 4? And main chart title. This is main chart title. And color, I'm using length of X. Okay. So rainbow, you know rainbow colors. Again, length of X. Length of X means normally rainbow colors are 7. Okay. But here X is how many numbers? 4 numbers. So first 4 colors in rainbow. See your output. Now your output is different. This is main chart title, and this is different chart. Okay, this is different colors. Okay, now the statistics. I think we need 1 day for 1.5 hours is not enough. So see, this is one variable, h equal to variable. Oops. Bar graph, already you have one. Bar plot of h. Similarly, now go to bar plot. See here. H is your data. M is labels. Bar plot. That is H. Names now dot arg. Name dot argument means first 7 is March, 12 March. 12 April, 28 May, 3 June, 41 July. Next, X lab. X lab means X axis name. Y lab means Y axis name. Color, your chart color is blue. And your main chart title is revenue chart. Border is red. Okay. See here, your output. See here, X axis name month. Y axis name revenue. Title chart is revenue chart. Your colors are blue. Each bar name is, first one is March, second one is April, third one is May, fourth one is June, July. Your borders are red. Is it visible? The red color is visible? Okay. Now, move to some other charts. Plot chart I'm taking, line chart. Okay, here I'm taking. No line diagram. See line diagram. I'm taking same data. Okay, plot this V. Type equal to O. Type equal to O means line with the dots. Line with the dots. Okay. Suppose plot in place of O, I'm taking only L. Okay. Now you can check only line. O means line with dots. Here also you can use color. See, your color is okay. Okay, I will go fast. There is no time. So H equal to, this is the data. I want to use some statistical functions. Mean of H. Yes. Mean, arithmetic mean. Okay. Median of H. So median. So mode, there is no separate mode function. You have to create the mode function. There is no mode function. Similarly, remaining geometric mean, harmonic mean, there is no separate functions. You have to create separate function. Okay, you have the process, and standard deviation. Standard deviation is variance of x. Quartiles Q1, Q2, Q3, Q4 like that. That is quantile. Quantile of x, comma 0.25. 0.25 means first quartile. This second quartile. This is third quartile. Okay. Now I'm taking some other graph, that is bar plot graph. So bar plot of H. See, sorry, not bar plot, box plot. Box plot. This is box plot. So this is box plot means it is a median plot. Okay. So median. See, this is maximum value, and this is minimum value. These two are outliers. Okay. This is middle value. This is middle value, and this is Q1. This is Q2, Q3. Q1, Q2, Q3. This is like median or Q2. Okay, this is box. Now, I want to use all functions in a single variable. All functions in a single variable. That is summary of H. Summary of H. See here. Minimum. First quartile. Median. Mean. Third quartile. Maximum. This is the. Okay. Now, can use some other functions. Because I have bivariate data. X equal to C of Just bivariate data. Know the correlation method, how to find the correlation of x comma y. Correlation. This correlation is 0.312736. Normally, you know the correlation formula. Correlation equal to covariance of xy by standard deviation of y. So you can use covariance also. Covariance of x comma y. Okay. R equal to use direct formula also. Covariance of xy by standard deviation of x. Standard deviation of R. There was a mistake. Covariance of xy by standard deviation of x, standard deviation. R must be lies between how it works. So 0.3127. Okay. Normally in correlation, so many types are available. Spearman correlation, Karl Pearson correlation. So default is Karl Pearson. So some other methods, what are they? Spearman rank correlation is available, and what are the remaining correlations? Kendall correlation, that is also you can use. So this is the default one is Karl Pearson coefficient of correlation. Okay, suppose I want to use Spearman correlation. That is very simple. Method equal to step. Method equal to speed. So this is Spearman rank correlation. Next.
Is it rank correlation, sir?
Yes, Spearman rank correlation.
Spearman rank correlation, yes, sir.
So default is Karl Pearson. So it is Kendall correlation. This is Karl Pearson. See, and I'm using Pearson 0.312736. Without any method, it is also 312736. So default method is default, showing default is Karl Pearson. Okay. Now come to regression. For regression is an average linear relationship between two variables. So regression. How to take regression? I have x and y. You can take y is a dependent variable, x is an independent variable. So here you can use some other variable, fit equal to LM. LM means linear model. That is a function. Adjusted R square remaining is available. Okay. For our basic student purpose, this is enough actually. Y is equal to a plus bx. We have to fit the line. We have to fit the line. By using summary of it, what are the residuals? Okay. What is coefficient of determination? What is adjusted R square remaining? We will get. This is about regression. Okay. Now we have 10 minutes. So I will extend our your time is up to 12:30 only.
Yes, sir, carry on.
Okay.
Hello, sir.
Tell me, sir. Tell me, sir. Purushakhar, sir, please.
Yes, sir. You continue, sir.
Okay, because within short period it is very difficult. I'm showing you very simple codes. Actually, we need some more explanation. Okay, so within 1.5 hours, it is very difficult to cover all the topics. So I'm going fast actually. Next one thing is, okay. Briefly, I will explain. Briefly, not no. Clearly, briefly, I will explain. Okay. So normally, you know, Poisson, binomial Poisson normal distributions in a probability. So what is binomial distribution? What is Poisson distribution? What is normal distribution? Everyone aware about these three distributions. Some more distributions are available, but these three are very basic distributions in statistics. So see the problem. See in binomial distribution, 5% of the items in large batch are defective. And if 50 items are selected at random, what is the probability that at least one will be defective, exactly 2 will be defective, 10 or more will be defective? So these are my questions. Okay. So 5% means that is a probability of success in binomial distribution. So 5% means 0.05 empty. So 50 items means n equal to 50 empty. Okay. Now, at least one will be defective. So at least one. So at least one means probability of x greater than equal to 1 will be defective. So x greater than equal to 1 means 1, 2, 3 up to 50. Or we can take 1 minus probability of x equal to 0. Okay, in form of 1 minus probability of x equal to 0. So x equal to 0 means you can insert x equal to 0 in binomial distribution. So what is binomial distribution? NCX probability of x q power n minus x. Just insert 0. The answer is 0.92. Now come to second one. Exactly 2 will be defective. Exactly means x equal to 2. So in probability in binomial distribution, x equal to 2, 50 So this is theoretical. Awesome. 10 or more will be defective. 10 or more will be defective. So x greater than equal to 10. Mathematicians, they are aware about binomial distributions. Okay. So this is the theoretical concept. So I'm using R code for same problem by using this problem. Okay. Now here there are 3 functions are available. There are 3 functions. 2 functions are available. Sorry, 2 functions are available. One is B binom. B binom, B binom. So B binom means suppose value x equal to 2 or x equal to 3. Here in this problem, p equal to 0.05, n equal to 50. Okay. Okay. N. Okay. This is the actual syntax. P binom. X. N. N means you know how many items. P. P means what is the probability. Okay. Now see this 0.9230. See here 0.923. So your syntax is x comma n comma p. Okay. So at least one will be defective. Now come to second one. Exactly 2 will be defective. See here. 4. It is a 4. D binom x equal to 4. Okay. Now I'm using same code for p binom. Sum of a See here, answer, this answer both are same because P binom takes cumulative probability. It's equal to X. Okay. Here I'm using two different functions. What is that function name is 1 minus sum of P binom 0 to 9. What is X? What is N? 50, 0.05. This is one function. Or directly I'm taking P binom only 9, 50, 0.05. Or, sorry, some mistakes are there. It takes cumulative probability. 1 minus 1 minus 3. Both answers are same. Both meaning are same. Okay. You can use the sum of D binom or P binom. See this answer? 0.0016. Now, similarly, come to Poisson distribution. You know, Poisson distribution is e power minus lambda, lambda power x by x factorial. So lambda equal to mean. So here, see this problem. Your roll of cloth contains an average of 3 defective per 100. Okay. Now lambda equal to 3 and n equal to 100. So what are the values? No defects we have to find. No defects means x equal to 0. Exactly 3 defectives. And exactly 3 or more defectives. So x equal to 0 means this is x equal to 0. X equal to 3. You know x equal to 3. X greater than 3 means 1 minus x less than 3. You can take x greater than 3 or 1 minus x less than 3. Because x greater than 3 means 3 to 100 you can take. That is very difficult. That's why I'm taking 1 minus probability of x less than 3. Okay. Now come to this one. This is also like same. Here also we have two functions. That is P Poisson. Okay. P Poisson. And P Poisson. There are two functions. Here also same. D Poisson is for exact probability and P Poisson is for cumulative probability. So here we can check don't need to mention n here. P Poisson x comma lambda x comma lambda, that is your syntax. Your output 0.049. See here, theoretical concept also 0.0. Second is also exactly 3 defectives. So exactly 3 defectives. 3 comma 3, 0.22408. Okay. Now come here. 1 minus probability of x less than 3. X less than 3 means 0, 1, 2. Okay. 0, 1. So I'm taking third one is 1 minus P Poisson. 1 minus P Poisson. What is that? I'm taking 2. Okay. 2 comma 3. 2 comma 3. Then check your output 0.576. So this is about Poisson distribution. So one is binomial distribution and Poisson distribution. Binomial distribution is D binom, P binom. Here also D Poisson, P Poisson. Syntax is different. In D binom, I'm taking X, N, P. Here I am taking x lambda, x your average, x lambda, because n and p are the parameters in binomial distribution, and Poisson distribution lambda is the parameter. That's why I'm taking this. Okay. Now, next one I'm taking, that is normal distribution. So this is about normal distribution. See here, you know, normal distribution f of x equal to 1 minus 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by whole square by. That is a probability density function of normal distribution. Okay. Again, you can convert that normal distribution into standard normal variate. Now, see here, just at large portal stay, an average of 9 days with standard deviation of 22.4 days among 1,000 guests. How many can be expected to stay? Less than 7, more than 14, between 7 and 14. Okay. Now, average of 9 days. You know, 9 days, that is mu. Standard deviation is sigma, that is 2.4. So in standard normal distribution, mu and sigma are the parameters. Now, among 1,000 guests, how many can be expected to stay? So first, less than 7. Okay, less than 7. You can use some normal tables actually. By using normal tables, you can find it. That is a manual thing. Okay. Next, more than 14 days. So greater than 14. Next, between 7 and 14. Between 7 and 14. Now, like binomial distribution or Poisson distribution, normal distribution also, same for P norm and P norm. P norm and P norm. Okay. So in P norm, your syntax is x, comma, mean. Normally mean we are taking mu, standard deviation. Y means mean and standard deviation are the parameters in Poisson distribution. Sorry, normal distribution. And he also said the concept no change, same B norm, same P norm. For exact value, I need P norm and use. For cumulative probability or summation of probability, I'm using P norm. Okay. Now come to this method, less than 7. So less than 7 means, normally less than 7 means, normally less than 7 means, less than 7 means 0 to 7. See, P norm 7. What is mean here? 9. What is standard deviation? Take your answer. 0.203. Okay, 0.202. Less than 7. Less than 7 means 0 to 7. So that's why I'm taking 7. 9 means mean, 2.4 is standard deviation. Now more than 14. More than 14 means more than 14. Anybody tell me? More than 14. More than 14 means 1 minus less than 14. Okay, so 1 minus P norm of 14, comma, what is your mean? What is your standard deviation? 0.018, 0.019, okay, into 1,000 they are taking, so 19 guess. They are taking the half into 1,000. Just here we are calculating only probability. Now, between 7 and 14 days, between 7 and 14 means 7 to 14. 7 to 14. Okay. So 7 to 14 means 14 minus 7 get. So P norm of 14, comma 9, comma 2.4 minus P norm of 7. Okay. 9, 0.7780. So 0.778 into 1,000 we are taking 778. So 0.77. So this is the normal distribution. And you can use bell-shaped curve also. That is also chances there. You can use bell-shaped curve, and also you can plot exact area of the graph also. Okay. So that is normal distribution. So now I'm closing the session. Actually, we have some pending concepts like hypothesis tests, design of experiments. Okay, but lack of time. Okay, it takes almost 1 day for hypothesis tests and design of experiments. So I'm closing the session now. And thank you very much to Tech University and the Tech University staff. Thank you. Thank you very much.
Thank you, Professor. Audience, please, any question?
Any questions? Yeah.
Sir, can we conclude the session?
So within short period of time, it is very
Sir,
difficult
we are
to.
giving for more much concept, sir.
Okay, thank you, sir.
Statistical maximum area you covered.
But
Basics
time-
fully covered, sir, and also hypothesis testing, everything also covered.
Hypothesis test and design of is not covered actually.
But probability,
Up to probability only covered.
yes, sir, yes, sir.
But I covered very fast actually.
Yes, sir, yes, sir. Okay, sir. Yes, sir. Can we conclude, sir?
Okay. Sir. Any questions?
Audience, any question? Yeah, madam, you are muted. Madam, please unmute and talk. You are muted, madam. Nazim, madam, you are muted. Please unmute and talk.
Okay, sir, between Python and R, sir, which is more user friendly, and will Python have more features, sir?
No, actually both are user friendly. Compared to Python, in R programming, especially for statistical analysis, we are using in R. In Python also we are using, but some other some advanced techniques is available in R only.
So between R and Python, how do you make a choice which package to use, sir?
You are a statistician, you can use R. Madam.
Okay.
You are a statistician, you can use R. Or you are aware about any computer science engineer, you can use Python.
Okay. Thank you, sir.
Thank you. Thank you.
Any other question, audience? Yes, sir. I think no questions, sir. Can we conclude?
Okay. Okay.
Now we conclude the session with a vote of thanks. Thank you, sir, for your excellent presentation. It is a very interesting session that will be of great assistance in the field of mathematics. Once again, thank you, sir. And I extend our thanks to all the participants for your participation. Now this session is over. Next session will start at 2:45 p.m. Thank you.
Thank you.
Thank you, Mukesh, sir.
Thank you. Thank you.
Yes, sir.